Welcome to solverfy.
In this problem, we have Young's double slit experiment, which consists of two slits, and light is going to shine through them. These slits are separated by a distance d. There's this distance here between the two lines I've drawn. At some distance away from here, distance L, there's a screen. And on the screen, we're going to see a sequence of bright spots and dark spots. So the central area is going to be bright, and then there's going to be dark, and then bright, and then dark, and then bright, and it's the same thing on the other side. So the circles here are bright spots. And the angle to these bright spots we're going to call theta. And the relationship here is given by d times sine of theta, and I'll say it's theta sub n, n referring to the nth bright spot, where the central one is the 0th. So we start at 0, this is 1, this is 2, etc. Equals n times the wavelength of the light being shined through here. Now in this problem, they want us to find the distance between the bright spots near the central bright spot. So that would be this distance, which I'll call x. Okay, if we look at this triangle here, x over L is tan theta. Right, this is opposite over adjacent. And what you have to notice here is that they're saying near the central bright spot, which means that this angle theta is going to be small. So tan theta, if theta is small, is approximately sine theta. So we can just substitute sine theta into here, and we have that d times sine theta, which is approximately d tan theta, so that's going to be approximately d times x over L, equals, and we'll just say n is 1. So this is the first one, between the 0 and the first. So that equals lambda. So we can now solve for x, which will be the separation they're asking for. X is going to be approximately lambda L over d. And now we just have to plug in the numbers they give us. So they tell us that lambda, the wavelength of the light shining through here, is 500 nanometers. And d, the separation between the slits, is 1.2 millimeters. And L, which is the distance to the screen, is 5.4 meters. Now we plug all this in, remembering that we got to get our units all in accordance with one another. So nanometers is 10 to the minus 9 meters, and millimeters is 10 to the minus 3 meters. We get that x equals 2.25 millimeters.